here. And Aiden's out. How's it? Right. Alright. As promised, we are going to go through oxy fuel safety setup, the different fuel types, kind of how to set it up, what's expected, how to be safe with it. We'll go over these videos, these instructional videos. You'll need to pay attention, and then we'll go out to the shop and show you guys how to set it up, what to look for, and all that good stuff. So make sure your phones are up, computers are up. Pay attention. We will be testing over this later on next week. If you'll need to move up closer, you can. I'll turn it up. I'll turn this front light down.
Oxy-acetylene welding. This is a
Everybody here?
very important piece of equipment for any shop. It's probably one of the most versatile pieces of equipment. Not only can we cut with it, gouge with it, we can weld with it. So it's has a lot of great options. We could also braze with it. Brazing happens below 840 degrees Fahrenheit and happens with capillary action. It's lower than the melting point of your base metals, so you don't actually pull in metal from the base, and it's used in close tolerance parts. Oxy-acetylene cutting has many different tips, and you choose your tip according to what size you're going to cut. Almost every manufacturer has a nice chart that shows what size tip you should use for what size cutting torch, and tells you what you should set your oxygen and your fuels at. This type of tip, which is unusual, is for gouging. Then we have our tips that are for welding, and they also come in different sizes according to the thickness that you're going to weld. Then we have our filler rods and our brazing rods. To oxy fuel cut or weld, you need to wear a 4 or 5 shade. You can use a face shield, which gives you good coverage, especially if you're doing piercing. Some of your welding hoods can go down to oxy fuel. You can also wear goggles, which works if you're just welding, or glasses that are that shade. We're going to use a oxy-acetylene setup. And our tanks, the bigger tank is under high pressure, is under 2,400 cubic pounds of pressure, where your acetylene is not under very high pressure. You can either have a 2-stage regulator, one of the gauges showing what's in the bottle, and one gauge showing what's coming out of the bottle. In the acetylene, they have a double line above 15, because the acetylene gets volatile above 15 psi's. You could use other gases, but if you use other gases, you have to use different tips. And you have to be sure that the tip that you're using is for the fuel that you're using. They're not interchangeable. The way you can tell whether the tip is for acetylene or other gases is by the marking system that's on the tips. The 1011 is for acetylene. If you're not sure, please check with the manufacturers. Either go to the website or go to your welding supply and be sure you're using the correct tips for the kind of fuel that you're using. Your torch is made up of several parts. This is a 2-part torch, which is very versatile. We can change the top section for either cutting or heating or welding. So it gives us a lot of versatility. The bottom section has a barrel, and it has a internal respirator. It also has internal flashback protections. We have quick releases on this torch to make it a little easier to change it from one torch to another. It's very easy to remove the top section. This should just be hand tightened. And you can see that there's O-rings inside. It's very important not to drop this, not to leave it out and exposed to the O-rings. You can damage your part. When you put it back on, it's hand tightened. You really should not use a wrench on it. It can damage the parts. Positioning is a preference. I like to put my valves up. It gives me a little more control. The gas is mixed in here, then the one mix comes through this part of the body. Oxygen comes through the top part of this body. And when you look at the tip has a center hole and it has preheating flames. And the center hole is for piercing the metal when it's reached its melting point. The outside holes are for heating. This valve here is for turning on the oxygen. And in the torch setup like this, you turn on your oxygen valve here and keep it wide open, and you control the valve from up here on and off for when you're using the torch. And the settling is controlled from this side. In most shops, this is a good way to start welding. You can weld a lot of different materials with oxyacetylene. You can weld aluminum and stainless with different fluxes and different fillers. You can weld cast iron, you can weld steel, and you can cut. So this should be the first tool that any shop should buy.
All right, a couple key points from there. Oxygen acetylene, that's what we use. You can also use propane as your cutting gas, but keep in mind you got to change out the tip. For our shop, we use oxygen acetylene. The acetylene is typically in a red bottle. We'll always be hooked up to the red hose. The oxygen is usually a green bottle. Be hooked up to the green hose. One of the biggest takeaways that you have to remember is acetylene is volatile over 15 psi. So what's that mean? It'll blow up. It can explode, right? So over 15 psi, acetylene is volatile. We have the two-step regulators on there. It shows you what's in the bottle and what's coming through the line. But it's important anytime you turn that gas on, with the acetylene especially, you turn it on slow to make sure A, your regulator is working, and B, it's not over 15. If it is, you need to turn the bottle off and then get in touch with me. That way we can get that regulator adjuster changed out. That way we don't have any kind of incident. So there's different tips. One we have set up right now is a cutting tip. Remember the center holes for piercing, the outside holes for heating. We use this to cut different thicknesses of metal, and depending on how thick it is, you can change your cutting tip to the different sizes. But remember, for it to be acetylene, you look on that tip, it should say 1011. So that's something to always check before you start working if you don't already know the equipment that's set up. Alright, so this is a quick video over setup and safety. Again, safety with oxygen acetylene is key. It can get volatile, it can
We're
start
going to go
fire,
over some safety
it can hurt.
issues with oxyacetylene cutting or using a torch. One of the most important things is the cleanliness of your area. You want to be sure that you don't have flammable materials around when you're cutting and you have open flames. You don't want to have any oil out, any rags. You don't want to have any wood in the area that you're going to cut. You don't want any aerosol cans or acetones. Make sure that your area is clear for 5 feet from the area that you're going to work. The first thing we should do is go ahead and check our oxygen and our acetylene cylinders. And we're going to go ahead and turn it on. But before we turn it on, we want to make sure this valve is out and we don't have pressure on our bladder. And you do not want to stand in front of a torch when you open it, because if it had a failure, this would come straight out. And you don't want it to hit you in the face. On your oxygen bottle, you turn it totally on and you crank it up so you can release the valve in this area. As you can see, we have gas in our cylinder. We have about 1,800 PSI. We don't have any pressure in our line because we have the valve released. We're going to turn this on, and we set our PSI according to the chart of what we're cutting. I'm going to set it to about 20 pounds. And I'm going to go ahead and check my lines to see if I have any leaks. And I'm going to use Snoop. It's a product that is a liquid tester. We can see we have a leak. So to take care of that leak, I'm going to use my crescent wrench, and I'm going to tighten it. I'm not going to muscle it down, but I'm going to make sure it's snug, because these are brass fittings. Then we're going to check it again and see if we took care of the leak. Okay, that's good. Now we're going to turn on our acetylene. Same thing. We're going to make sure this valve is released. If you did accidentally take the valve totally out, it's okay, just screw it back in. On acetylene, we go only turn it half a turn. That way, if there is a problem, we don't have much to turn back. This is at 100 PSI. You can see this is not a high pressure cylinder like the oxygen is. We don't have any acetylene on our line, so we're going to add about 5 pounds of acetylene and check this one for leaks. Do have a little bit of a leak. Remember, this one is left-handed, so I'm going to tighten it up, and we're going to check this one again. Okay, that's good. We're going to check the torch area for any leaks, and everything looks good. So this torch is ready to go.
All right, little recap, important things off that particular section. What is volatile again at acetylene? 15. So when we're setting our acetylene, what are we looking for cutting? 5. So when we set our acetylene, we want to make sure that valve's off so there's no pressure on the line going out. We turn on our bottle slowly. Like I said, it's a 2-step gauge, so the one will show us what we have. A full bottle is typically a couple hundred PSI. It's not a high pressure like the oxygen is. The oxygen will get over 2,000 PSI, depending on the size of the bottle. But you want to make sure, we crack that open slow to make sure, A, we don't have leaks, B, it doesn't shoot up and our regulator pops out. The second key thing is, like she said, don't stand right in front of the regulator, right? If it was to have a fault, it can pop out on you or hurt you. So always stand to the side, make sure you have your safety glasses, and crack it open. You want to keep that PSI when you're cutting with acetylene at about 5. Anything over that is overkill. Then your oxygen, you crack the bottle, make sure your regulator's going, then you can go ahead and crank it wide open. Like I said, should be a full bottle's around 2,000 PSI. You want to crack that regulator to where it's running between 20 and 30 PSI is typically what we'll use to cut metal, depending on the thickness. One thing she said that stands out, or a couple things, acetylene, which is the red bottle, red hose, is left-handed threads. Do you guys know what that means? What's it mean?
It means it's backwards.
It's backwards. So typically we always say righty-tighty, lefty-loosey, right? We're tightening it to the right. Well, on this one, we tighten it to the left. Basically, it's reversed from what we normally do. The oxygen's normal thread. It's a right-handed thread. You tighten it to the right to tighten it. The acetylene, you go to left. The biggest reason for that is safety, right? Make sure you don't get them crossed. You can't tighten the acetylene, or excuse me, the oxygen hose onto the acetylene and vice versa, because they won't go. So that's a safety feature they put in there for that, because you don't want to get those mixed up, cause a lot of problems. Again, when we're cutting, you always got to watch your surroundings. You got a flame coming out. You got to make sure you're not around sawdust or something that can catch. Typically, the flame's going to be controlled within, 8 to 10 inches. But you want to make sure that heat's coming off. It's not hitting anybody. You want to make sure everything's clear around it. and make sure everything's picked up. Cylinder safety.
It's very important that these cylinders are in a cart and they are tied down.
Please come to the office.
Anytime that you move these cylinders outside of the cart, you need to remove the regulators and cap them. You should never move cylinders without caps on them.
It's so hard to get good at that.
If you don't have a cart,
It is.
then you need to be chained to a wall. Anytime these are in use, they need to be chained or in a cart. The acetylene bottles are full of pellets and they absorb acetone and they produce a gas within the cylinder. If you're moving these bottles and they're laying down, you can't use them for welding until they've been vertical for 4 hours. It's very important that you make sure that your gauges are on tight. You use a wrench. Your gauges on your acetylene are left-handed. They have a score in it, where the ones on your oxygen are right-handed and they do not. That way you can't interchange them. This one also has a male fitting, where this one has a female fitting. On your hoses also, the connections that are for acetylene are left and have a score, and for oxygen they don't, and they're right, so you can't confuse them. Do not use Teflon tapes on your threads unless you're sure that these are oil-free Teflon, because oil can cause the explosion with oxygen. When you use wrenches on your oxygen, they have to be oil-free, because oil can cause the explosion. You never oil any parts that are on oxygen acetylene.
Piece 2 is the little line, right? So that's another way to tell it. Your red hose should go to the acetylene, green should be oxygen. That's kind of your standard colors. And remember, which we should never have this issue, we should never lay down an acetylene bottle on the side. There's really no reason we don't storm that way. When we get new gas, they don't bring it that way. But if it was, it needs to be vertical for at least 4 hours to be able to produce that acetylene correctly. The big thing too is thread tape. We never use thread tape. And my experience is don't even use it even if it is oil-free. Just, you don't need it. It can explode with oxygen, any kind of oil or lubricants. And so that's a big no-no with any kind of oxygen acetylene setup. Never do it on the torch, never do it on the valves, any part of that. Remember, this is brass. Brass is a soft metal. It's not like mild steel or anything else. It's soft metal. If you over-tighten it, it is going to mess the threads up. It's going to bend them. It's going to mess up the torch. It's going to mess up the coupler. It's going to cause it to leak. So you want to hand tighten the top of the torch like she showed you, but when you're tightening with an adjustable wrench onto the bottle itself or onto the regulators, you always want to snug it but not over tighten. It's easy to over tighten with brass. You can strip it or mess it up really fast. So that's something to make sure you watch for.
Acetylene is just one choice of fuels. There are many others. Some people choose to use naphtha or propane. You can use natural gases. You can even use hydrogen. Each flame is different. Whenever you make a choice of what type of fuel you're going to use, you should also check to see what is different about that fuel and make sure you have the proper tips for that fuel.
Again, there's different types of fuels. For our shop, we only have acetylene and oxygen, which is the most commonly used. And that'll probably be the only ones we keep. So.
Do you have to buy like certain types of regulators for the?
I'm going to demo just lighting
Yes.
the torch.
So you will have to have certain specific regulators for oxygen acetylene. You couldn't use a regulator that was on like a welder. They're specifically made for that type of gas and for the different pressures. you know, with this acetylene being such a low PSI at the bottle, right, it's not going to read the same as like an oxygen regulator. So the PSIs, the markings, all that's going to read different, so it's specific to the gas you're using. If we were to ever change the acetylene out to like a propane, not only would we have to change the tips, we'd also have to change out the regulators. And
Before you light a torch, make sure that you have gloves and face shield. Also make sure you do not have any lighters in your pockets and your area is clear.
What's going to happen if there's a lighter in your pocket?
When you light it, you start by cracking your acetylene.
Explode in your pocket, burn your
I'm
eyes.
going to bring down my face shield.
Y'all shouldn't have lighters in school anyway, but if you're ever at home
Do
or on a
not
farm.
point near your bottles. You turn the acetylene on until you see the smoke reduce. That tells you you have enough acetylene for the torch that you're using. Now add oxygen until I see nice cones. At this stage, we're at a carburizing flame. Now we're at a neutral flame, but to check it, you hit the lever, bring the cones back in. That is a good cutting tip. To turn it off, I turn off the oxygen first and the acetylene. If you hear a pop when you're turning off the acetylene, you have a dirty tip. And the answer to that is not to turn back on the oxygen and blow out that way, or to turn your oxygen off last so you don't experience the popping. Take the time to clean your tip.
All right, so went over that. Now we're going to step right back here in the shop, and I'm going to go over that kind of hands-on what we just learned, show you all what we mean when we're checking regulators, what to do, how to light the torch, what to check for. So if you want to come on, we'll grab some safety glasses in the box by the door, and then we will grab, have one of y'all go grab some cutting goggles that are back there by the welding booths.
I got it.
Remember, it has to have a 4 or 5 shade on the goggles or glasses or face shield. They do make face shields. They do make face shields, just like our clear cut shields that are tinted specifically for torch cuts, which I'll get some. We have those green goggles or the red goggles set up, and then just bring a bunch of them. So we can check. Face shields? Yeah. Alright, y'all can stand right over here. I'm going to set it up right here. Y'all come over here. I'll set it up. Yep, no, you're good. Most important, like I said, these goggles, as they flop down, they pick up, you can see through them, you can face it down once you get it lit. You notice compared to a welding hood, they're not as dark, right? You can actually see through them. That's because this isn't as bright or as intense as hard or stick welding. So it gives you more control and the ability to see. If you were using a welding hood, you'd be struggling to see the cut or what was going on. Alright, so this is our torch card, right? We have our acetylene, which is the red bottle, our oxygen, which is our green bottle. Remember, they are secured. Anytime it's on this card, this cap is off, and it has to be secured to the card being chained. Never move this card if these aren't chained, right? We need to find the chains. If this chain was to break, we need to get it fixed. We don't need to use it. We don't need to just go on about our business. We need to stop. If this was to fall without this cap, what's it going to do? It can blow off. Remember, this is the weak point. We can create a missile or torpedo. It can hurt. It can hurt you. It can hurt walls. It'll go do anything it hits. Typically, the acetylene, like I said, is not at a higher PSI compared to the oxygen, but it's still enough to mess you up. Okay? So, we got a few things that are torch card. We have our striker striker. So what this is a metal striker, has a flint piece in the middle. You'll strike it to create your spark. Keep your striker here at the car, that way you don't lose it. You always want to make sure you store your cutting torch. Don't let it drag, don't let it fall. We're going to mess it up. Remember, this whole thing's brass. If we start dropping it, we're going to damage it. It's not going to work, or it's going to leak, which can cause other problems. Now, we've already used this and checked it, so all the leaks are good. This is that two-part torch that we talked about. Your red is your acetylene. Your green is your oxygen. This top is also your oxygen. This is a cutting tip. We have a brazing tip or a welding tip on that one. But if we're ever cutting metal, cutting pieces to weld, cutting pieces on that trailer or anything else, we use the cutting tip. Make sure the tip's clean. You see the holes? Remember that center hole's for piercing, the outside's for heating. If it starts to pop or get spackly, it's because this tip's dirty. There's a specific little file that you'll use to clean them out. Don't just try to blow on it, never run water or anything else through it. Use those files to clean it out. So remember, we want a 5-foot space around us. I know that's close, but we're not cutting. I'm just showing you guys. We moved it over here. Typically, we'll be up there on the metal side working, but make sure it's clear. Make sure there's nothing going to catch on fire. Always remember, check your surroundings. Right? Once you light this, you don't want to just be waving it around and your friend walks up not paying attention. You hit their arm and burn them. So before we turn our bottles on, we want to make sure everything is turned off here. So again, you take it to the right. So your valves turn off to the right. Just your connectors. This one's left-handed, meaning it goes the opposite way to tighten. This one's right. But your on-off valves all turn to the right to turn off, turn to the left to open. It's important to make sure they're all off, tight, before we turn our gas on, because if they're not, the gas is going to start coming through. Right? So you can hold this right here, or you can set it right here while we turn our bottles on, because we made sure it is not on. So you want to start off with the oxygen. This is a 2-step regulator, right? If you're short like me, you may want to get up and look. Turn it on. If you ever have a question which way is on and off, it says on top, but you'll turn to the left to turn it on, turn to the right to turn it off. You want to turn it on. Once you realize, okay, our regulator is good, just go ahead and crank it on open. Don't take it all the way out. This valve comes out. Crank it a few full turns. You have these set, but remember, if you're cutting, this top one is how much PSI is in the bottle. This is a new bottle, so it's got 2,000 PSI. That's a lot of pounds, right? Pounds per square inch. This bottom one, if you look on the inside, which is the gray, is the PSI we're looking at. Right now, with no oxygen flowing, it's about 35. So what will happen once we turn the oxygen down or on, it'll drop a little. But to set that, we will crank it up. Sometimes it won't drop. Set it's too high and it won't drop. We may have to crack our oxygen. Start it, and then crank this valve down so it's where you want it. Okay? Turn it back off. You got that set. Typically, this regulator will hold it. It shouldn't change. So once you set it, you shouldn't mess with this. Okay? Once it's set, don't be cranking these. Remember, if we crank this the wrong way and we get in a hurry, this goes over 15 PSI. It could cause problems. So make sure you guys are paying attention to that. So we're good here. Everything's on. Now we can
Well, David,
our
please come to the office.
Remember, don't stand in front of this. Right? Why? It can blow off. It can hit you. It can hurt you. So the chance of that happening is not very likely, but it could. So we always got to treat it like it's dangerous and make sure we stand out of the way. So you crank this open. Slow it till you see it go up. This top one is how much pressure is in the bottle itself left. This bottom one is what's coming through our hose. So we're sitting at about 60 PSI left in the tank. Like I said, remember this one full is only about 200 PSI. Even though it's a big tank, it's not high pressure, okay? High pressure gets you in trouble. We're sitting at 10 PSI. You'll see at this bottom, that gray, you see where it turns to red? It's got that marker to say that's dangerous, right? So you always want to keep it down. This one's up a little high. So to set this, to get it to go up, we can turn it, but to make it go down, we need to relieve the pressure. So we can turn this on. You see it drops down, but it's still running about a 6. We want it about a 5. So we just crank it down. So we're sitting at about PSI. Keep in mind, once you turn this off, it's liable to go up a couple pounds, right? But once it's on and running, we want it at about a 5. So anytime we're cutting, typically most metals and thicknesses, 20 to 30 PSI on your oxygen, about 4 to 6 PSI on your acetylene. Really 6 is the max. 5 is kind of where you want to stay. Always check this before you start cutting, okay? So again, we make sure all our valves are cut off or closed off. And to light it, which one do we start first? Y'all remember what they said? No, acetylene. You always light with your acetylene, not your oxygen. So it's the red, right? So how do we light it? We crack it. Just crack it slowly. You take your striker. The gas isn't going to hurt you, but don't face it toward anybody, right? You want to keep your valve, your hose out of the way so you don't trip on it. And you hold the striker in front of it, and you light it. See how much soot that is? It's physical, you can get it on you. You want to add acetylene until that flame, or excuse me, the smoke, right at almost disappears and the soot goes down. Does that make sense? So you don't want to crack it open where it's just blazing. You see that gap? Can y'all see the gap in the flame? You don't want that gap, right? It's not going to cut or do anything right. You want to dial it back to where you close that gap. It's about right there. Add till the smoke kind of starts to dissipate. Okay, so that's about where you want your acetylene. Again, make sure this one's closed. If this one's closed, go ahead and open your oxygen. Open it slow just to make sure the valve's not faulty. And then go ahead and crank it on open. A couple of good turns, wide open. Remember, not to press this. This is your cutting lever. If you press this, it'll probably blow it out until we get it set. So don't press this by accident. I would always put your hand under it. So this is where we adjust our oxygen. We got our acetylene on. We got this oxygen valve open, but this is where we actually adjust the amount of oxygen mixing and going through. So you crack it slow. If you crack it too fast, what's going to happen? It'll go out. Watch. See? It's not going to blow up, but it'll always go out. So you got to crack it slow. So we'll turn everything off and start again. If that happens, turn your oxygen off first, your acetylene. You always turn oxygen on first, or excuse me, acetylene on first. Light it, turn your oxygen on, adjust it. When you're turning it off, when you're done cutting, always turn oxygen off first and then acetylene. So acetylene, oxygen to on, oxygen, acetylene to on. So just reverse. Does that make sense? Okay. So we'll reset it. You're at our striker. Everything's off. We'll crack our acetylene again. You don't have to crack it where it's going to shoot hard. Just enough to get it started. You can add more. So that's about where you want it right there. Put our striker down. Make sure this is off again. Make sure you don't hit that valve. We're good there. Open it on wide open. And then you grab your oxygen and you slowly crack it. Sometimes it's tight. Turn it to the left. Open it. You see the flame changing? It's mixing, right? So when I bring it down to that carburizing flame, which is about right there. So once we do that, we're going to dial it down a little more to a neutral flame. Typically, I always tell people you want that cone. You'll see that cone on the inside. You'll see that? You want it about an inch. Sometimes you can bring it in a little more, but really that's about where you want it to do a good cut. It's going to mess up a little, but once you squeeze it, you put this on. If we were cutting, you want to do this will just help after a while. If you were just lighting it, you don't have to have your shade on, but once you start cutting or looking at it more than a minute, you want to have your shade on. Protect your eyes. Yes, it's not like welding where it's going to cause flash burn, but if extended periods of time, it will cause eye damage and burns. So now that we've got our flame where we want, we start heating the metal, and once we get it cherry red or glowing, we press our oxygen, and that's going to be locked up. So, once we're done with that, to cut it off, we just simply cut off this oxygen right here, which cuts off that completely. Then we go ahead and cut off our bottom oxygen. There's no need for it to be on. Cut it off. Then we cut our acetylene off. And that's it. Okay. One more important thing to remember. After you get done, if you're the last person using it or when you finish, right now we still have 6 PSI on this hose. We still got about 30 PSI on our green hose, our oxygen, right? So how do we get rid of it? Turn the bottles off, and it's called purging the lines. You always need to purge the lines anytime you cut. So how to do that is you turn your bottles off. Remember, if you ever need to know, look on top. It says close or open, right? Close them off, get them tight so we don't have any leaks overnight. Oxygen and acetylene, especially acetylene, is expensive. We always want to make sure we don't have leaks, but we want to make sure we turn it off so there's no leaks formed and we don't waste gas, okay? So turn them off tight. Okay, we still got PSI, right? We got 6 PSI plus that. So how do we get rid of it? You start with your acetylene, you simply crack it. You'll watch this bottom regulator, which is the pressure going into the hose. You open it, you see it went down, right? We purged our lines completely. It's empty, there's no pressure. We don't have to worry about gas seeping out. We don't have to worry about messing these seals up while we're not here. Same with the oxygen. Remember, once we open this, it doesn't come out. Why? Because this top one's not open, or if you don't want to open the top one, you can simply bypass it with this and add more oxygen and let it go out. You hear the oxygen going out. You can watch your pressure go down from 30 psi to 0. Once it's out, I always like to make sure all the valves are closed again. That way, next time you double check it and it's there, right? You don't ever want to get in a rush and skip these steps. Like I said, it's very important to make sure these lines are purged. That way, there's no pressure on your regulators. If you keep pressure on these regulators and lines, like I said, at some point it's going to cause that. All right, so when you're done, what do? Wrap it up, right? We said this is brass. These are expensive. Our hose setups are expensive.